So we're going to continue on with sine law. So we're going to have sine law. And when last we discussed things together, we were solving for side length with sine law. We said that sine law can solve for either side lengths or angles. And all of the examples that we've done up until now were for solving of side lengths. So today we're going to look at sine law, but now it's going to be solving for unknown angles. Okay, so sine law, solving for unknown angles. Lovely. So recall there were two variants to sine law, A over sine A, B over sine B, C over sine C. And then there was sine A over A, sine B over B, sine C over C. And the tip I give you is remember that put what you're looking for in the numerator. So I'm going to write that out again. So put what we are solving for in the numerator and top. Okay, and if we remember that, then it should make it easier. So recall again as well when we're labeling off triangles. I'm going to draw this on here. That on the vertices, on the corners, uppercase letters go. So imagine we said this is W, and this is X, and this is Y. Now, these are not good ones to choose because it's hard to tell uppercase from lowercase. Nevertheless, if those are the uppercase, the lowercase go here. So W, X, and Y. Okay, so we recall that. Now, if I'm looking for an angle, I'm going to have this variant. I'm going to have the sine of A over A. Now, I'll be careful. You don't have to have this variant. This makes it easier. Sine of A over A, sine B over C, no, over B, my goodness, equals sine of C over C. Now, in this case, I labeled it like this. It doesn't really matter what these letters are. This is just representative to help us remember. So if I wanted to do it for this triangle, I could have said instead, this is the sine of uppercase X over little x equals the sine of uppercase Y over little y equals the sine of uppercase W, I'm in the wrong order, whatever, W over W. There we go. So if we're looking for angles, and these are angles, right? The uppercase letters represent angles. So let us look at an example. So let's draw in a straight-edged triangle. So imagine that we had the following triangle. Okay, so there it is. And we knew the following. So let's say this side looks to be about 8 meters. This side looks to be about 6 meters. And I'm going to tell you that this, I don't know, this looks to be like 42 degrees. And I want to solve for this. I want to solve for X. You think, okay, well enough, all good. Now, when we go to solve these things, after a while, you'll just start to think about the ratios that go. So, you might jump right to saying, okay, this angle goes with this side. So you could have said, the sine of 42 over 6 is equal to, there's an angle there, the sine of X over 8. And like, I'm happy for you to jump right to that. But until you get comfortable with that, you can just label off the vertices. So just by default, A, B, C, which means this is little a, this is little b, this is little c. So if I think, all right, it's going to be the sine of A over A equals the sine of B over B equals the sine of C over C, and then fill things in. So, there's sine 42 over 6 equals, there's nothing there, so sine B over little b equals the sine of X over 8, right? And if we looked at this, we're always looking for a complete ratio. There is our complete ratio and a half complete ratio. Well, this one isn't half complete, has nothing. So I can't use that one. And so here is my half complete. So I would then write them side by side, which is what I've got right here. Again, if you're feeling comfortable and you think you can jump right to this, have at it. And so now I need to solve. All right, so here's where it gets a bit more challenging. I know I want to get the X all by itself. So, all right, so if I start working through things backwards, grab another color here, this color. I can see that this expression is being divided by 8. Well, the opposite operation of dividing by 8 is going to be to multiply by 8 and multiply by 8. Those 8s are going to go away. They're going to divide out. They're going to become 1. And I'm left with the sine of x is equal to 8 times the sine of 42 over 6. And I could type that into my calculator. Absolutely could type that into my calculator and get a number, right? So I'll do that right now. And I'm going to show you, and that's not really wrong. But again, it's, the more we can do to keep our decimal places around till the very end, the better. So I'm going to do 8 times the sine of 42, close that bracket off, divided by 6, okay? And I see that that's 0.89217. So I'm going to do that off to the side, 0.89217, 0.89217, and that's equal to the sine of x. And then we can say, well, I don't want the sine of x, I want x. We talked about what's the opposite operation of sine, and it's sine inverse. So I can really sine inverse both sides, and I could write that out. Where I just know it's going to be the sine inverse of 0.89217 is equal to x. Okay, is equal to x. Now, I've kept a lot of decimal places there. But you might think, but you only said we need to keep 2 decimal places. Well, 2 decimal places is what I want at the end. I want you to keep track of decimal places throughout. So if you're good with your calculator, you don't want to hit clear, right? Like I could hit clear there and then get rid of it, but I don't want that. I really want all of those decimal places. So I would type in second function sine inverse. Now on my calculator, to get the last answer, I can do second function answer. And a lot of you have a comparable facility on your calculator to do that. So I didn't lose any decimal places in that calculation, and I got 63.15 degrees. Okay, so I come back here and I say that's 63.15 degrees. And that's actually the exact answer. But let's look at how the answers change depending on how many decimal places I take. So if I did sine inverse of just, 0.69 or 0.89. So if I just did 0.89, right? How does that change it? Probably not a lot, but it's going to change it, I bet. Yeah, so look, it goes from 63.15 to 62.87. And some of you are like even more cavalier. They're like, 0.89, that's practically 0.9. So if we did second function sine inverse, that's not what I wanted. Second function sine inverse of just 0.9. And it's off by a lot, right? It's off by more than a full degree. So with trig, more than nearly any other unit, keeping track of decimal places is really important. Okay, so we really want the answer to be 63.15 degrees. So back to what I said would be a preferred solution is I would then say, all right, I don't have to take the sine inverse. So on this side, I'm going to end up with just x. And on this side, I'm going to have the sine inverse of all of that, 8 times the sine of 42 over 6. And if you get to a position where you're kind of handy on your calculator, I'm going to show how I can type it in on mine. It would type it in on any 2-line calculator the same way. So I'm going to do sine inverse and then bracket. Sometimes calculator doesn't put in a bracket. I need to put a bracket. That represents that one. Of 8 times the sine of bracket, again, mine puts it there, 42. Close that bracket. That's this bracket right here. And then divided by 6. And then I need to close that bracket. So close that bracket. And all in one go, it ends up as 63.15, which is what I got here because I kept track of all of my decimal places. So the key is that I want it to be 63.15 degrees. Okay, so there it is. X equals 63.15 degrees. And really, that's it. That is the method that we're going to use for solving for angles. So I'm going to do another couple of examples with you live here, sort of, that I would like you to pause the video after I've drawn up the example, and then you can check your results when it's done. All right, so here we go. So another triangle. Now I'm going to tell you there's an interesting thing about, that's not a straight line, about sine law that we don't really cover in 11 middle math. If you were taking 11U, we would learn about something called the ambiguous case. And so I just want you to hear that word. So sometime you might get a weird answer. And if you get a weird answer and you're not sure what's happened, let me know. Shoot an email to me, and it might actually be an ambiguous case. Nevertheless, imagine that we knew that this angle here that doesn't look very big. Let's just go with a bigger angle. This looks a little bit bigger than 90 degrees. How about 93 degrees? And this side is x. No, we need to know a side length here, not x. And this side is, I don't know, 5 centimeters. And this side is, I don't know, looks to be 12 centimeters. And what I would like to know, folks, is I would like to know the measure of this angle right here, this x. So go ahead, pause the video and give it a whirl, and then come on back. Welcome back. So I know I can't use SOHCAHTOA or all. We know what we're doing sine, right? So I'm looking for an angle. So I can say that it's going to be the sine of angle x, and that relates to this side right here. So sine of x over 5 is equal to the sine of 93 degrees. Well, and that relates to this side over here. So of 12. Good, set this up. You know, on a question like this would be worth just a simple one like this, probably 3 marks, and you get a mark just for setting this up. Now we need to solve. Sine x is being divided by 5, so I'm going to multiply both sides by 5. 5s are going to go away. And then I have the sine of x is equal to the sine of 93 degrees over 12 times 5. But I don't want the sine of x, I just want x. So the opposite operation of the sine of x is the sine inverse. So in theory, I could write the sine inverse on both sides. I don't really need to do that. I know it's going to end up being x is equal to the sine inverse of this whole shoot and match. So this is the sine of 93 over 12 times 5. And I can type that into my calculator exactly as it appears. So grab my calculator. Second function, sine inverse of open bracket, that's this guy right here. And then I got a second bracket, so bracket, the sine of, there's really brackets here as well, sine of 93. Close that bracket and then divided by 12. Close that bracket and then times 5 bracket equals 24.59 degrees. So that's going to be x is equal to 24.59 degrees. X is equal to 24.59 degrees. And there it is. Okay, zoom right there. Okay, lovely. Let's try another one. Let's try and spice this one up a little bit. So I think this is red. Red, yeah, hopefully. All right, so let's try another triangle. That looks black to me, but I think it's red. Okay, so yeah, we're back. How about if we know side angle? Yeah. So, okay, this is going to be 15 centimeters. This is going to be less than that, so 11 centimeters. And I'm going to tell you that this angle here is, I don't know, 64 degrees. And what I would like you to do is I would like you to solve for this angle here. So go ahead, pause the video, and give that a whirl. Welcome back. So here we go. I'm going to set this all up. I know I'm looking for this x right here. So I know that it's an angle, so I'm going to put it on top. So the sine of x over, well, this x is related to this 11. So sine of x over 11 is equal to the sine of 64 over, well, this 64 is related to this 15, and I'm going to solve. I know I need to multiply by 11. Multiply by 11. Those guys are going to go away. And we're going to do that the sine of x is equal to the sine of 64 over 15 times 11. Like that, and you know, theoretically there's brackets here. I want to get x all by itself, so we're going to say x is equal to the sine inverse of the sine of 64 over 15 times 11, and I'm going to drop that into my calculator. Okay, so grab my calculator, and we're going to do the sine inverse of 2 brackets, and then sine 64, close that bracket, divided by 15, close that bracket, times 11, and then close the final bracket. And we're going to get 41.23 degrees. So x is equal to 41.23 degrees. Okay, lovely. So we'll end it off on one that's a bit more of a challenge. So can we, yeah, I don't know, whatever color this is over here. That looks right like red to me as well. So let's do this one, whatever this is. Maybe orange, I don't know. It's still on a straight line. Let's pretend it's a straight line. So if we said this side is 18 meters and this side looks to be 16 meters, and we know that this angle here is, how about if we made this 60 degrees? Here's what I want. This is going to get a little bit tougher. I want this over here to be X, and I want this to be Y, and I want this to be Z. So we're going to, this is called solving the triangle. So solve the triangle, which means find all of the unknowns. So this is where we really probably want to get into our labeling practice. So I'm going to label off. I'm going to grab a different color so it's easy to see. This color. A, B, C. Remembering that the vertices have to be uppercase. This is lowercase a, this is lowercase b, this is lowercase c. So I'm looking for everything, but so maybe I don't know which version of sine law to write. So imagine that I write it like this. So imagine I said, okay, it's going to be sine, or A over sine A equals B over sine B equals C over the sine of C. And then we fill everything in. So A, well, that's 16 over the sine, what's the sine of X? Equals B, well, B is Z over the sine of B, what's the sine of Y, equals C, lowercase c, well, that's 18 over the sine of C, well, that's going to be the sine of 60. It's like, okay, we're good. Because what I have is I've got a complete ratio, right? And I can't use this one right away because it's got variables in both places. So I don't feel very good about that. But this is a half complete ratio. So if I go and I write those things side by side, which is always a good idea, we're going to have 16 over the sine of X is equal to 18 over the sine of 60. It's like, oh, dang, I'm looking for the thing and it's in the denominator now. We could solve this easy peasy. We could cross multiply. But we can also just say, well, I wish I had written it the other way. And you can go ahead and you can just flip the whole thing. So we can say this is going to be the sine of X over 16 is equal to the sine of 60 over 18. And then just like the ones we've been doing. So I'm going to multiply both sides by 16. Multiply by 16. Those 16s are going to go away. And then I'm going to sine inverse both sides. We're going to have X is equal to the sine inverse of the sine of 60 over 18 times 16. I'm going to drop that into my calculator. Okay, so here comes my calculator. Yep. So we're going to do the sine inverse of the sine of 60 divided by 18 times 16. And when I do that, I'm going to keep, it's going to be 50.34 degrees. Where's my pencil? There it is. So X is equal to 50.34 degrees. So I can go back up here and I can say, huzzah, this is 50.34 degrees. And now this ratio is a complete ratio. So it's 16 over the sine of 50.34 degrees. And that's equal to Z over the sine of Y is equal to 18 over the sine of 60. And it's like, okay, I have two complete ratios. There's a complete ratio and there's a complete ratio. And then I also need a half, but I'm still, this is not a half complete ratio. It's got two variables. But we're clever enough to realize the three angles in a triangle have to add up to 180 degrees. So we can solve for Y. So we're going to take Y and solve. We're going to say, oh, that's going to be 180. And I'm going to then subtract off the 60. And then I'm going to subtract off the 50.34. And I do that, and I'm going to find that it's 69.66 degrees. So I know that this is 69.66 degrees. So I can come back and say, haha, grab my eraser here. Where is the hard eraser? There it is there. I'm going to clear this out. Yoink. And we're going to go back here, and we can say, this is now 69.66 degrees. And now we've got a half complete ratio. So this is where we're going to have to exercise some caution. In theory, any complete ratio and a half complete ratio will do. So I could use this ratio and this ratio, and it would work out as long as I got that one correct. But if I got this one wrong and I used it, even if I did everything else correct, Z is going to be wrong. So it's always a good idea, always, 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 to go and use the original complete ratio. So those are absolutely the two you should use. So we're going to have Z over the sine of 69.66 degrees is equal to 18 over the sine of 60. And we recognize here that Z is being divided by the sine of 69.66. So I'm going to multiply both sides by the sine of 69.66 degrees. So I'm going to multiply this side as well by the sine of 69.66 degrees. And over here, those are going to divide out to be 1 or cancel out. We're going to have Z equals, and I'm going to type this into my calculator. So here we go. So we're going to have that. We have 18 divided by the sine of 60. And we're going to close that off. And then I'm going to multiply by the sine of 69.66 degrees. When I do that, I'm going to find out that it is 19.49. So Z is 19.49. And there it is. Okay, there it is. So what we've got is we were able to solve that triangle. It required a little bit of, jumping around. We had to solve for an angle first, then we use that to know that the sum of the angles in the triangle is 180 to solve for this one, to solve for the final piece. So that's kind of everything there is to know about the sine law. So I'm going to stop the lesson there. And what I'm going to do is I'm going to upload some questions for you to practice. Thanks, guys. Bye.